This is my third go at doing this check your learning. For some reason it keeps taking the video sideways when I upload it. I do not know. If any of you know how to fix a sideways video in YouTube, I will pass you in physics. Rightio. So the first couple of questions in this check your learning are pretty straightforward. I'm not too interested in those. I think you'll be able to do those without any help from me. Don't forget you've got the worked answers if you need those from Richard Walding on Oxford. And also I think I've sent them out to you or attached them in the learning place. Let's look at 5 and 6. They're a bit more interesting. Propose the maximum flux you can achieve through a loop of wire with a perimeter of 100 centimeters in a 5 millitesla magnetic field. Justify your claim with a reasoned explanation. So we've got to come up with it and we also have to justify it. Now, I want to just draw your attention to this loop of wire. It keeps talking about loops, loop of wire, loop of area, this, whatever else, rather than just talking about through this a plane of a particular area or through anything else. It keeps talking about a loop. And the reason it's talking about a loop is because this is the start of electromagnetic induction, and we are looking to build towards looking at the interaction between electric fields, and magnetic fields. And to do that, you need a loop of wire. So all of these will say loop, just like in generator or motor. Rightio. So loop of wire. Perimeter of 100 centimeters, 5 milliteslas. We need to know what area we can get from 100 centimeter perimeter. And do we want a big area or do we want a small area? So over here I've already had a bit of a go at this because this is my third go at this video. So we've got flux, which is what it wants us to find, is the magnetic field strength by the area. So the bigger the area, the more magnetic flux. So we want a big area. So if we look at some of our options, square gives us this area, rectangle prototype here gives us this area, and lo and behold, a circle. We work backwards from the circumference to get the radius and then the area. It actually gives us the biggest, indicated by this tick. And that was the size of our magnetic field. So we just need that area that we calculated, magnetic field, and this is the flux measured in Webers. Now, for justify with a reasoned explanation, I don't think there's anything wrong with this as an explanation. You can see that I've tried different perimeters. You might add in a sentence that says a circle gives you the maximum area and therefore the maximum flux. So we could add that in. Circle gives max area, therefore max flux. Right, there we go. Perfectly reasoned, no worries at all. Answer seems very small, but then our magnetic field was in milliteslas, so small answer makes sense. Okay, question 6. A loop of area 0.1 meter squared has a perpendicular parallel to the magnetic field. Student claims that the change in flux will be the same when the plane is rotated from 0 to 30 degrees as it was when it's rotated from 30 to 60 degrees. So it's going to be fairly straightforward. We're just going to need to calculate the flux at 0. I accidentally touched the screen. I don't know what that did. I don't know. I think it changed the focus. Sorry. At 0 and 30 and get the difference between. Work out the magnetic flux when it's 60 degrees and get the difference between. So that's done in your text answers, which I foolishly clicked off before. That's not yours. That's yours. what did I want to tell you about? There it is, the text answers. Oh, yes, it doesn't give us the size of the magnetic field in the question. So they've just left that as B because the magnetic field size isn't going to change. So they've left it as B, and it's 0.1 B Webers, 0.87 times B Webers. Then they've just done a difference over here, and the negative sign just indicates that from going to 0 to 30, you've got less flux than you had, and going from 30 to 60, you've got less. So both of these have got negative answers. And they've just left B there. It doesn't matter what the size of that magnetic field is. It's the same in all of them. So there is a greater change in flux from 30 to 60 degrees. Now, change in flux is important because it's a change in flux that creates or induces an electric current in the wire when you're looking at a generator, or vice versa with a motor. So if you just put a wire in a magnetic field and just sit it there, it's not going to run a current through it. It's not until you start moving the magnetic fields around in relation to the wire that you get an electric current induced. So that's why that's important. I should never have touched the screen. All right, so if you know how to flip it in YouTube, please let me know, because as I said, this is my third go and I'm getting a bit cranky. Okay, thank you.